Welcome back. I'm Muammar Lone, and in our previous episodes, we've explored how to represent text numerically and create sophisticated word embeddings. Today, we're diving into one of the most practical aspects of NLP, supervised learning. How do we teach machines to make intelligent decisions about text? Imagine teaching a child to sort their toys. You show them examples. This is a car, this is a doll, this is a block. After seeing enough examples, they can sort new toys on their own. Supervised learning works similarly. We teach machines through examples. But instead of toys, we're dealing with text classification, sentiment analysis, named entity recognition, and more. Let's start with a real-world example. When you flag an email as spam, you're helping train a supervised learning system. Today, we'll uncover how these systems work and how to build them. Understanding supervised learning. At its core, supervised learning in NLP is about teaching machines through labeled examples. Basic components. 1. Input. Text, documents, sentences, words or phrases. Features we extract. 2. Labels, categories, sentiments, named entities, true, false decisions. 3. Learning algorithm. Pattern recognition, weight adjustment, error minimization, prediction generation. Let's look at a simple example. Input: this movie was amazing. Label: positive sentiment. Input: terrible service, won't return. Label: negative sentiment. The machine learns to associate positive words with positive sentiment, negative words with negative sentiment, neutral words with context, patterns with outcomes. Text classification fundamentals. Text classification is one of the most common supervised learning tasks in NLP. Common applications. 1. Email classification, spam detection, folder organization, priority assignment, topic categorization. 2. Content moderation, inappropriate content detection, language filtering, safety monitoring, policy compliance. 3. Customer service, query routing, intent, classification, priority assignment, response, suggestion. 4. Document organization, topic classification, genre detection, language identification, structural analysis. Let's build a simple classifier step by step. 1. Data preparation. 2. Feature extraction. 3. Model selection. 4. Training. 5. Evaluation. Naive Bayes classification. Let's start with one of the simplest yet most effective classifiers, naive Bayes. Key concepts. 1. Probability theory. Prior probabilities. Conditional probabilities. Bayes' theorem. Independence assumption. 2. Implementation. Word frequency counting. Probability calculation. Prediction generation. Confidence scoring example. Document. Quick delivery, great product. P positive document, a P document positive, P positive, P document. Breaking it down, P positive. Probability of positive reviews, P quick, positive. Probability of quick in positive reviews, P delivery. Positive, probability of delivery in positive reviews. P great, positive. Probability of great in positive reviews. P product, positive. Probability of product in positive reviews. Support vector machines, SVM. Moving to more sophisticated approaches, let's explore support vector machines. Core concepts. 1. Feature space, high-dimensional representation, linear separation, kernel tricks, margin optimization. 2. Text applications, document classification, sentiment analysis, language detection, topic categorization. Example. Implementation. 1. Feature extraction using TF-IDF. 2. Kernel selection, linear, RBF polynomial. 3. Parameter tuning. 4. Training and validation. 5. Performance optimization. decision trees and random forests. Now let's explore tree-based methods for text classification. Decision trees. 1. Structure. Root node. Internal nodes. Leaf nodes. Decision paths. 2. Text features. Word presence. Term frequency. Pattern matching. Structural elements. Random forests. 1. Ensemble method. Multiple trees. Random feature selection. Voting mechanism. Robust predictions. Practical example. Topic classification. Sports. Contains score? Yes. Contains team? Yes. High confidence sports article. Benefits. Interpretable decisions. Handle mixed features. Capture complex patterns. Robust to outliers. Deep learning for text. As we move into deep learning, the possibilities expand dramatically. Neural network architectures. 1. Feed-forward networks. Dense layers. Activation functions. Dropout regularization. Batch normalization. 2. Convolutional networks. CNN. Text convolutions. Feature detection. Pooling operations. Deep representations. 3. Recurrent networks. RNN. Sequential processing memory cells. Long-term dependencies. Bidirectional processing. Example tasks. 1. Sentiment analysis. Fine-grained emotions. Aspect-based sentiment. Context understanding. Temporal analysis. 2. Named entity recognition. Person detection. Organization identification. Location extraction. Date recognition. Advanced techniques. Let's explore some cutting-edge approaches. 1. Transfer learning. Pre-trained models. Fine-tuning. Domain adaptation. Few-shot learning. 2. Multitask learning. Shared representations. Task relationships. Efficient training. Better generalization. 3. Active learning. Smart annotation. Uncertainty sampling. Query strategies. Resource optimization. 4. Ensemble methods model combination, voting schemes, stacking boosting. Evaluation and metrics. Proper evaluation is crucial for success. 1. Classification metrics. Accuracy. Precision recall. F1 score. ROC curves. 2. Cross-validation. K-fold validation. Stratified sampling. Time series splits. Bootstrap sampling. 3. Error analysis. Confusion matrices. Error patterns. Bias detection. Performance analysis. 4. Model selection. Hyperparameter tuning. Model comparison. Trade-off analysis. Resource considerations. Real-world implementation. Let's look at practical implementation considerations. 1. Data pipeline collection. Cleaning. Augmentation. Validation. 2. Model pipeline. Feature extraction. Model training. Evaluation. Deployment. 3. Production system. Scalability. Monitoring. Updates. Maintenance. 4. Quality assurance, testing, validation, error handling. Performance monitoring. Future directions. The field continues to evolve. 1. Few-shot learning. Limited data scenarios. Quick adaptation. Transfer efficiency. Domain generalization. 2. Interpretable models. Decision explanation. Feature importance. Confidence estimation. Bias detection. 3. Efficient learning. Resource optimization. Quick training. Model compression. Edge deployment. 4. Ethical considerations, fairness, transparency, accountability, privacy. Howard. Closing. As we conclude our exploration of supervised learning in NLP, remember, data quality matters. Features drive performance. Evaluation is crucial. Implementation details count. Ethics guide development. In our next episode, we'll dive into unsupervised learning techniques. Until then, try this exercise. 1. Collect text samples. 2. Label your data. 3. Extract features. 4. Train different models. 5. Compare results. I'm Muammar Lone, and thank you for joining me in this journey through supervised learning in NLP. Remember, every label teaches and every prediction improves. Keep learning, keep predicting, and I'll see you next time. Stay curious and keep classifying.